All right.
Live.
Yeah, we started at 3:11. We started at 3:11, so it was 3:21. Okay. Well, this is Group 3 squad.
Week 3, Lesson 4. Coming live.
From the
MC and Mason's house.
Yep.
what's the area?
83440.
Can you hear us, Mason?
We'll be live tweeting this session. Hey, did you find your thing yet?
I'm looking for my
Let me just look on mine.
the prep assignment.
Yeah, that's what I'm looking for right now too.
Okay, so the first question on the prep assignment is what notation is used to denote probability? I think it's the P with the X in the parentheses, like it's a function.
Yeah, like X being whatever it's going for. Like if it's dice, then X could be 6, or depending on whatever the question is going to be.
Yes.
The 3 rules.
Want to do number 2?
Go. Yeah.
So the 3 rules of probability. The probability, number 1, the probability of an event is a number between 0 and 1. Number 2, if you list all the outcomes of an experiment, the probability that one of those outcomes will occur is 1. So the sums of all the fractions will add up to equal 1. The complement rule, the probability that an event will occur is 1 minus the probability that it will occur.
Cool.
Right.
And a probability will never exceed 1, right?
Right.
It's impossible. Or you're doing something wrong.
Let's think about that. Never exceed 1.
Yeah, well. Okay, so what does it mean to be random? I put that it has a long-term pattern, but you don't know the next experiment.
Yep. That one's pretty self-explanatory.
Yeah.
To explain random. So the next one would be, what does the phrase discrete random variable mean? What's the difference between that and random?
I think discrete, you can list all the values.
Well, that makes sense.
Yeah. And then
Cool.
1 do 5, 6.
So you roll an 8-sided dice. What is the occurrence that the number will be greater than 5? So 6, 7, and 8. So it would be 3 8s, which is 37.5% chance of rolling a 5 higher than a 5.
Yep. And then for the last one, or that's what I got as well. And the last one was a 5 out of 8 chance, which is 62.5%.
You add those together, and we get 1, which is rule 2.
Did you guys have any questions on the assignment or things that were kind of hard to understand?
Let me look at the reading. I feel like the reading has some stuff that was. Finding the mean. Do you remember what a standard deviation is? Is that the? I don't know.
The average, like the average away from the average.
Oh, right. Okay. No, seriously, I didn't remember.
This one actually doesn't really make sense when I was reading it. The probability that an event will not occur is 1 minus the probability that it will occur. Do you understand what that means?
So say the probability that you'll roll a 3 is 37.5%. You do 1 minus 0.375.
Oh, and it's 625.
625. So it'd be 62.5% that you don't roll.
Complement.
The opposite.
Complement. Alright, that makes sense.
They explained it kind of weirdly, more complicated than it needed to be, in my opinion.
Yeah.
All right, let's do the quiz.
Okay.
Group meeting quiz.
On
I've kind of looked over it a little bit already, and it looked pretty so far. Didn't look hard.
I'll read question number 3.
I
Types
think
and the proportions given in the table above define a probability distribution. So human blood can be classified into our basic types O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. So 45% have O, 40% have A, 11% have B, and 4% have AB. So blood types and proportions given define a probability distribution.
I think it's true.
The probability, or is that just, yeah?
I would say true.
Yeah, they add up to 1. Yep,
Yeah, they do.
good with it. What is the, I guess Matt, you got this one?
Okay, what is the probability that a randomly selected person has type O blood? I put 0.45.
Yep.
45%, yeah.
And then what is oh, you go ahead, you can do 5.
I'll do the next one. So what is the probability that a randomly selected person will not have type O blood? So it's 1 minus 0.45, right?
Right.
Which equals 0.55, 55% chance.
Yep.
Yeah, 0.55.
Okay.
We are on 6.
Yeah, let's do all the reading.
Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. What the heck? The dogs were trained to lie down next to a specimen derived from a bladder cancer patient.
Tangle dog's name.
Wrap my head around that previous sentence. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 vials contain urine line of
Bowls.
Yeah, bowl.
You said bowels.
7 bowls. Well, we're talking about bladder. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as bladder cancer patient. If the dogs guess at random, what is the probability that will correctly identify a dish containing the specimen from the bladder cancer patient?
So there's 6 dishes. 1 of them has cancer.
And there's 7 bowls.
No, I thought there was just 6 bowls. Oh, there is 7 bowls.
Yeah, there's 7 bowls.
So 1 divided by 7 is 0.143.
So what is it asking? What the chance of choosing a what?
The cancer patient.
Okay. And what'd you get for the? What'd you get?
0.143.
Okay.
Okay, in a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very, very unlikely that the dogs would do this well by random chance alone. Which of the following statements is most appropriate? So this is what I wasn't sure. So 22 divided by 54 is a 40. So they got it right 41% of the time, which is a lot more than the 14% of the random chance. But so I put this provides strong evidence that they can detect it.
I think that makes sense.
I mean, it's still not very accurate, 40%, but It's a lot more than 14.
Well, this is like, because it's like just dogs detecting it versus like actual
A test.
test and stuff. So I think that's pretty good.
It's for me too.
Hmm.
I
So
think because it's greater than the, what's the word? The probability.
Yeah, the probability of random probability.
So let's go with that one for now.
Okay.
So I'll read, use the following information to answer the next 3 questions. M&Ms are small chocolate candies. The M&M website previously indicated that in the U.S., the distribution of the colors in a bag of plain M&Ms is given in the following table. Green does not want to be shown. So
Okay, do you want to read the question?
If you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy? We need to know the green percentage, though, don't we?
Yeah, I already figured it out. So when we get to that question, I
What
got
is it?
The green is going to be 16.
16%?
Mm-hmm.
No, just I think
A red-colored candy?
the red is 0.13.
Or
The next question.
are we supposed to figure out what green is? Or
Yeah,
That's question 9.
oh, that's question 9. Okay, so it's the 0.13, and then the green was what, Aaron?
0.16.
All right. Is not green, so it'd be 86%.
84.
Oh, 84, I mean.
Yeah, that's what I got.
Are you guys putting 0.84?
No. I'm not a chemistry major.
All right.
When I click save, it puts. Oh, wait, no, it doesn't. What the heck? I don't know. Whatever. I don't think it matters. Okay, for the last one, it's got some ACT scores from a college. Question 11 is half of the observations are less than or equal to what number? And this is a review question. So it's not data, it's just giving us the minimum, the first quartile.
So that'd just be equal to the mean, right? 24.3?
See, I thought maybe it'd be equal to the median.
No. Nothing.
Because the mean would be the average. And the average doesn't necessarily.
You're right, because if like a bunch of people scored high, I think it is the median.
What do you think, Mason?
What's the quartile again? I forgot.
So there's 5. There's the max,
Oh,
the max, the min, the middle, and then the 2 and 3 quartile.
First and third.
First and
so
third
it'd be
quartile.
quartile 3.
Well, no, the first one means 25%. 25% of the people scored in that one. Then
Oh,
between 25 and 50% were between 1 and the median.
Yeah, it totally is the median.
You think so?
Mm-hmm.
Okay.
I think the mean would be close, but I don't think it would be.
And I think if it was a decimal one, it would also say round to it. So, based on the information, the top 25% of the students scored above what number?
Would that be would that be the Q3?
That's what I thought, the Q3. 27.
0 to 25, 50, 50 to 75, 75 to 100. Yeah. Did you say Q3 or 27?
I put 27. And then, did you get that one, Mason?
was that question 12?
Yeah.
Yeah.
Question 12 is 27. And then for 13, it's asking which one of these is not one of the 3 rules. And the 3 rules are that it's between 0 and 1, that the probabilities add up to 1, and that the
Complement.
Yeah, and the complement one. So I put the third one.
If the probability is high, then the positive Probability is positive. Yeah, you're not gonna have a negative probability.
Yeah. And then just for 12, you guys got 27. Is that what it was?
Yeah, does that make sense why?
Yeah, the top 25% because, yeah, that makes sense.
All right.
Oh, I put median. It needs to be a number.
Yeah, you can't write median for question 11.
Yeah.
You have to actually put the number.
How many? Alright.
And don't forget to put true for that you did the individual
Actually-
prep assignment.
Yeah. Okay. True. Got it.
All right.
All right.
Let's,
I'm gonna end the.
I think we're good for our video, yeah?
yeah, we got 16 minutes.
1 second.
All right.
Video.
Perfect.
Oh, I forgot to record. No, just kidding.
It says live at the top.
Okay. I'm gonna stop the